Okay, a question from June 18, R variant 32. Okay, to solve this equation here. So in such equations where you have the equation is in terms of this complex number here. So you should start by saying that let this z is x plus iota y. Therefore, your conjugate would be x minus iota y. So this is 3 into x plus iota y minus iota into x minus iota y. That is 1 plus 5 iota. So this is 3x plus iota y minus iota x plus iota square y. Now this is better to just write in terms of
3x
iota
plus
first
3 iota
rather than
y.
doing it. Yes, beta?
Sir?
Yeah, this is
3x
3.
plus 3 iota y.
Thank you, Beta. 3 iota. Thank you, Beta. Thank you. That you just noticed it because you were doing it. That's great. Okay. So it's 1 plus 5 iota. So then we have 3x and from here minus y. Okay. 3x minus y. So we have 3x minus y, and this is I'm just going to take iota common here. This is going to be 3y minus x iota, that is equal to 1 plus 5 iota. Okay, so we put the real part equal to the real part and the imaginary part equal to the imaginary part. So this would give us 3x minus y equal to 1 and 3y minus x, that is equal to 5. And then you solve these two equations simultaneously, you will get to your solution. So I'm just going to multiply this equation with 3. This is 9x minus 3y equal to 1. And I'll just add it with this equation. Okay, that is equal to 5. So this is 8x, that is equal to 6. Again, keep an eye on this working. This is 3 over
Sir,
4.
here for 3x minus y is equals to
Equals to
8.
8 because
Oh,
9x minus 3y is equals to 3.
oh, you see, again, I was making a mistake here. So that is going to be equal to 8. Okay, thank you. So I just told you that keep an eye on this. Okay, x is 1. So this is going to be 3y minus 1 equal to 5. So this was a very nice kind of a question because we're getting the exact values here. Okay, so therefore this complex number z is 1 plus 2 iota. And if you want to mention its twin brother, so that is going to be 1 minus 2 iota. Okay. Okay, in the second part, it says on a sketch of an organ diagram, shade the region. So we have to do the shading. Just remember what to do. Shade the region whose points represent complex number z, which satisfy both the inequalities. Modulus of z is less than or equal to 3, and imaginary part of z is greater than or equal to 2. So we have done all of this, okay? So when it is modulus of z, that is equal to a, if you remember that thing. So this is basically a circle from the origin with the radius a, okay? So now we have a circle from the origin with the radius 3, but this time this will be inside the circle. The things will be inside the circle. So this is, I have here. Okay, this is my uh, very bad kind of line here. Okay, I think this is enough. And then I have this one, z is, so z from the origin is, okay, now this z is not the one that we have got from the previous equation, okay? So I'm not going to take this is not the given thing over here, okay? This is the part B, so this is altogether a different part, okay? So I was making a mistake by considering taking z from the previous part, okay? So z from the origin is 3. So if here it is the origin, so this is going to be a circle of radius 3. So I will be marking 1, 2, 3, and then 1, 2, 3 here, okay? And then from here, this is 1, 2, 3, and then from here, this is going to be 1, 2, 3. So these are the points through which this is going to pass. So this is 3 here, this is minus 3 here. So if you take a good scale here, so this will really help you to draw that circle accurately, okay? So this is the origin here, 0, 0, okay? So now, so I'll try my best to draw a good circle. Yeah, this looks better. Okay, so we have drawn the circle. So this means that our complex number z is somewhere inside this circle. And then next it says imaginary part of z is more than or equal to 2. So here is the 2 iota. So I have to draw a line like this, and there is a line like this. Okay, so this is your um, 2 iota. So this z has to be, if I just shade this with, let me shade this with this black color. So this is the region where we have our complex number z. Got it, bacho? Here is the region where we have this complex number. Okay? Yes? क्यों भाई?
जी सर.
है ना? अच्छा, next it says, now calculate the greatest value of argument z for points in this region. Greatest argument. Now this is the region we have. Now if I mark this point as A and I mark this point as B, so at which point do you think we'll have the least argument and where we will have the greatest argument? Where can I have the greatest argument and where can I have the least argument?
A and least at B.
Yeah, we have greatest at the point A, and just focus on this shaded region, okay? If I draw a line like this, if I just assume that, okay, my complex numbers location is this, then this is the least argument over here, okay? And if I take this as its, this is the extreme position that we can have here. So you see that this much is going to be the greatest argument over here, okay? Now you have to use your O-level trigonometry to find this an angle from here and then to determine that argument. Now, what is this length OA? Hurry up. The length OA.
3.
That is 3. That's great. Okay. And if I call this point C over here, so what is the length OC? That is 2. Okay. If you find this angle, there is a right angle over here. Okay. This angle would be same as this angle. Okay. Let me call this theta, and this is going to be theta. So how can we find this theta? Please keep your calculators mode in radians. Can I say sine theta is equal to 2 over 3? That is simple trigonometry. And your theta is sine inverse of 2 over 3. Once you get to this, your final answer would be pi minus this theta. Who will tell me what is the sine inverse of 2 over 3? Correct to 3 significant figures.
0.730.
730, okay? And now do that pi minus answer. So what do you get?
Sir, 2.4.
Yes, hurry up.
The
The
2.41.
2.41.
Okay, this is 2.41. That is the greatest argument. Now we are open for the discussion. Please ask if there is any question.